Dear students, today I am going to teach you about an algorithm in data mining called as a priori algorithm, which is used to generate frequent item sets. We'll see how. So, introduction. Already we have seen about classification and clustering, and now we are seeing one of the data mining tasks called as association rule mining algorithm, which is used to generate association rules that will express the associations or the correlations among the different data items what is present in a given database. So this mining can also be called as frequent item set mining or frequent pattern mining. And association rule mining is popularly applied in market basket analysis. That is, when you enter into a supermarket, we carry a basket along with us and we purchase a lot of items. And the businessman is very eager to know what are all the items and customer is buying together. That is the correlations among the purchase. So this he calls as the purchase behavior. So this will help him to improve the business. Okay. So in market basket analysis, we are trying to generate association rules which will tell the buying of which item is implying the buying of another item in the shop, which will help the businessman to improve his business. And it is also used in weblog mining, where we perform analysis called clickstream analysis on the log file maintained in a web. So the clickstream shows how we are navigating from one site to the other. So this is normally there is a pattern followed by a user when he makes a surfing on the internet. He clicks the pages what he likes, and this clickstream mining will help to improve the satisfaction of a web user. So normally this association rule mining is done as a two-step process. One is to find the frequent item sets. The second is to generate the strong association rules from the first step. That is item sets which are generated from the first step. But in this video, I will be showing only the first part, that is how we are going to generate the frequent item sets. So the input to this process will be normally a type of database called as transaction database. That is the billing database what is maintained in a retail shop or a wholesale shop. So here every item in the database refers to the different products what is available in the supermarket, like bread, butter, egg, jam, etc. Item set refers to, like the name set, it's a collection of items, that is collection of bread butter together or butter jam together or bread and jam together, etc. We call an item set as frequent item set if it is very frequently purchased in the given database. And this can be mapped to other applications like as frequent pattern, where it can be used to find the frequent regularity which is occurring in the data. And this regularity or frequent item set is determined using an algorithm called a priori algorithm. That is the main focus of our video. So frequent item set, whenever we want to evaluate, so as I told earlier, item means it is a different products which is available in the shop, and item set is a collection of products what is bought. And we say that a item set which is bought in a shop is frequent if it is purchased by many customers. So this we have to evaluate, that is whether an item set is frequently purchased or not. To perform this evaluation, always we need some metrics or measures, and here in this algorithm we have two measures. One is called as the support, and the other is called as the confidence. So support is, suppose if I want to determine whether buying of a product A is implying buying of the product B, then I can do that with the help of the formula that can be determined with the help of the formula, that is a probability of the occurrence of A union B. It is, probability is nothing but, as we all know, it's a ratio between two things. So ratio between the number of transactions in which A and B occurs divided by the total number of transactions. Similarly, confidence is given by the formula probability of B conditioned on A, that is the ratio between the number of transactions in which B occurred out of the transactions in which A occurred. Okay. So in other words, we can write the probability, conditional probability as, so whenever it is conditional probability, in the denominator we will be having this condition, that is the number of transactions in which A occurs, in which B also occurred. So that's what is given as the transactions in which A union B divided by the transactions in which A occurs. So support means the number of transactions in which A and B together occurs divided by the number of transactions in which A occurs. The meaning is, out of the total number of transactions in which A occurred, how many times B also occurred. Okay. So the meaning of this one is, what is the total number of transactions in which A as well as B occur together? So that determines the support count of this implication, that is A. Buying of A is implying buying of B. And now this algorithm uses a very important property called as a priori property. And the property states that all non-empty subsets of a frequent item set must also be frequent. So before proceeding, we should know what is called as frequent item set in this algorithm. And the set of all items whose support count is greater than a threshold what is specified by the user, then that is called as a frequent item set. Say suppose I am having a frequent item set, say A comma B, or say bread comma butter. And the user is saying that if this combination occurs in at least 5 transactions, that is at least 5 customers have bought bread and butter together, then that combination is frequent. So now I go and count the number of transactions in which people have bought bread and butter. If this combination support count is greater than 5, greater than or equal to 5, then I say that the item set is frequent. Now, the a priori property is, if you generate all possible subsets of a frequent item set, then all these subsets will also be frequent. Okay, so that's a priori property. That is, in other words, you can say that if a particular set itself is not frequent, that is buying of bread comma butter itself is not frequent, and there is no way that buying of a combination of this set is not frequent, that is a superset. Say for example, buying of bread and butter is not frequent. So absolutely it is not possible that buying of bread, butter and jam will be frequent, because bread and butter itself has not occurred in more than 5 transactions, which means that there is no chance that another one item combined to this set, it can occur more than 5 times in the transaction. Okay. Next is, it works in 2 steps. One step is join step and the second step is prune step. In the join step, we are trying to generate item sets called as candidates. Normally, the rule is a candidate K item set will be formed from the frequent item sets which is generated in the previous iteration, that is K minus 1 iteration, or the frequent K minus 1 item sets. So normally the frequent item set is denoted by the symbol L, and L K minus 1 stands for the frequent K minus 1 items. So from this K minus 1 frequent item sets, we are going to generate the input for the next iteration, that is the candidate K item sets. And the join condition says that we can join 2 item sets in the frequent item set combination LK minus 1 only when the 2 item sets differ in the last position and in all the previous positions they are equal. Okay, that is, for example, again I will say a 2 item set A comma B comma C, and there is another item set A comma B comma D, and this can be joined now because in all the previous positions they are equal, that is A is equal to A, B is equal to B, and we are differing only in the last position. If that is the case, then you can join the 2 item sets to form candidate K item set. So when you join, naturally what you will get? You will get A comma B comma C comma D. So we have formed a 4 item set from a 3 item set. Okay, so that is a rule. Next is a prune step where we are going to scan the database and determine what is the actual count of these candidates what we have generated from the join step. If the count, the support count, is not satisfying the minimum threshold, then these candidates cannot be frequent, and so they are removed or pruned from the next iteration. Similarly, we are going to use a priori property also for pruning. That is, if a set is not frequent, then the superset cannot be frequent. Even that is going to be considered for pruning. So with this, we will start a demo. So this is a transaction database what I am going to take. So this has 9 transactions. So if we see 9 transactions, each with different items which are purchased. So in transaction 100, they have purchased item 1, item 2 and item 5. In transaction 200, they have purchased item 2 and item 4, etc. So the first iteration of a priori algorithm, we are going to make a scan on the first iteration. We have to form one item set. It is a first iteration, then in one item set, candidate one item set. So the total number of items present in the given database or I1 is there, I2, I3, I4, I5. So it's in the range of I1 to I5. So I have listed all the one item set here, and from the table I have counted the number of transactions in which each item occurs. So I1 occurs in say 1, 2, 3, 4, 5 and 6. So if you see, the count will be 6. Similarly, the item I2 is count, and we have to count the number of transactions in which I3 occurs, and we have to count the number of transactions in which I4 occurs, and the number of transactions in which I5 occurs. And now we check this with the minimum support. So now I consider the minimum support as 2. So if an item is occurring at least in 2 transactions, then I can say this particular item set is frequent. So if you see here, all the items have occurred for at least 2 times, and so all is considered as the frequent item set. So they have been taken to the set L1. So first we are starting from C1, which is the candidate set, and we are resulting in L1. The second iteration, we have to do the join step. That is, we have to make a join of all this one item sets to form 2 item sets. So that is, I1 should be combined with I2, I1 should be combined with I3, I1 should be combined with I4, and I1 will be combined with I5. But we will not make combination of I2, I1 because already we have formed the combination of I1, I2. And similarly, we will not make combination of I3, I1 because already we have made combination of I1, I3. So the next 2 set combinations will be I2, I3, I2, I4, I2, I5. Next is I3, I4, I3, I5. And the last one is I4, I5. So if you see the second iteration, we are going to join every one frequent item set to form 2 candidate item set. And we are going to eliminate all those supersets whose subsets are not frequent. That is the usage of a priori property. Since all the item sets are frequent in this one item set, all the supersets what can be formed from this frequent item set will be naturally, there is a chance for them to be frequent. So here we will not make any pruning using a priori property. Now we are going to scan the database to find the support count of each candidate item set. Okay, and then if they are greater than or equal to the minimum support, then we will say they are frequent 2 item sets now. And this we will repeat for the third iteration. And this iteration will continue till we don't get any further candidate item sets. If there is no candidate item sets for a next iteration, if the candidate item set is empty, then the algorithm will stop. And the output will be nothing but all the frequent item sets generated. There is a 1 item set, 2 item set, 3 item set, etc. So if you see, this is a demo showing the output, that is the generation of all the candidates, and then we are making a scanning of the database and we are listing out the support count. And if you see now, few of the sets don't satisfy the minimum support because they are lesser than or equal to lesser than 2. In which case the frequent item set, 2 item set is only 3, 6 combinations. And using this frequent combinations, now we are going to form 3 item set combinations. And here all the 3 item set combinations is not resulting because we have to check with the a priori property. By satisfying the a priori property, we are going to hold only those item sets whose all the subsets are frequent. And again we will go for a scanning in the database, and we'll take the support count. If the support count is greater than or equal to 2, we retain that in the L3 and the algorithm will stop once there is no further generation of support count. Thank you.